Okay, so here in this question, they're telling you have two bodies, P and Q. They form a system. Okay, after some interactions, Q has lost 80 joules. So that means in the opposite way, it gained negative 80 joules. Okay, and P gained 60. This is not a non-isolated system, because a non-isolated system, they don't lose energy. And here, they started off with 80, but the other body has 60. So body Q has gained 80 joules, it's obviously correct, but the system has gained 140. You don't add the joules, okay? The system has lost 20 joules, it's correct, because they started off with 80, and the body P gained 60 joules. So the system lost like 20. It's kind of like forward. There's not really much explaining to it. The system is isolated is wrong, obviously, because they don't end up having the same amount of energy. And the system gained negative 20. So lost is 20 joules, gained is the opposite, so it would be the negative of losing. Okay, understanding this question will help you understand like the other questions that talk about energy. Okay, this question will help you understand the other questions in this quiz about energy transfer. So what you need to know is when in an isolated system, when an object loses energy, that energy goes to the other object. So when object A loses energy, this energy goes to object B. Okay, so object A loses the 30 joules. That means that object B gains the 30 joules. That's why they have like an inverse relationship. Here you're given the mass, the gravity, the work, but not the height, and they want you to find the height. So the formula is just W equals to mgh. Mass is in kilograms and height is in meters, and you just find h. For this one, they want the body that's gaining energy. So if you're going in the opposite direction, obviously you're not gaining energy, you're losing energy, or you're just unbalanced. And then the third one, when you have a force acting like on the right or on the left, and then like you like another one, not a force, like the motion is up, nothing happens, like just nothing's gonna happen. Same thing for the last one. I don't know how to properly explain it, but like just nothing happens. If the direction of the motion is up but the force is on the left, nothing's gonna happen. But if they're going both in the same direction, then you're gonna gain energy. Okay, when the motion is going in the same direction of the force, it's motive. If it's going in the opposite direction, then it's called resistive work. Here they want you to find the work, which is just normal, it's just FD. But they give you an angle. When you have an angle, you do the same thing, but you have to multiply it by cosine theta, or cosine the angle. So you just do W equals to FD times cosine and 45, the included angle. That's it. For this one, they're asking for the kinetic energy, and the formula for kinetic energy is half mv squared. Okay, and then the answer that you're gonna get for this one is 160,000. Okay, which is not the answer, 160,000 joules, but they want it in kilojoules, so you have to divide it by 1,000, and you're gonna sorry, I forgot a zero. You have to divide it by 1,000, and you get 160. Okay, for this one, they gave you all this information, and they want you to find the speed of the car after moving the distance. So the only equation that's given, like that we took, that included speed is this one, which is called the work energy theorem, I think. Yeah, okay, but it requires, we have everything we need for it but work. And what's work? Work is FD. So first find work, you're gonna get this number, then substitute all the numbers here, and obviously the initial velocity is gonna be 0, so if you substitute 0 in here, it's gonna turn out to be 0. So just find this and isolate the v, and that's it, you're gonna find it. This one is W equals to FD, which is 25 times 2, and it's 50, okay? But it's negative because they're asking you for the work done by the frictional forces. Frictional force is equal to the normal force, like the force acting on the object, but in the other direction. So it's just negative. For this one, they are asking you again for the speed. So we're gonna do the same thing we did in the other question. We're gonna find the work first and substitute it in the work energy theorem, and you'll find V. That's it. Also, I forgot to mention that in the question they specified that the force that they gave us, which is 3 newtons, is opposite to the displacement. So the force is -3. So that's why the work is negative. Okay, don't forget that. Okay, again, this is energy transfer. So the energy gained by one body would be the negative of that energy gained by another body. So energy gained by body P is plus 50. The energy gained by the other body would be -50. That's why the net change, when you add them together, it's 0. For this one, you have to know, when they give you this type of question, you have to know like I said in the other question similar to this one, when you have an angle, you have to use this formula, W equals to FD cosine the angle. Okay, when they tell you the work done by the weight, the angle is always 90. Okay, because it's like this, right? So the what's it called, the angle is 90. Okay, and then when they tell you the work done by the normal reaction, what's the normal reaction? Normal reaction and weight are equal to each other basically. So obviously again 90, it's the same thing. This, when they tell you the work done by the pushing force is what? This force. So it's just the regular force, which is 60 degrees. But the work done by the friction, okay, here they told you, what's it called? It's not they gave you what the frictional force is, which is 10. Okay, so it's not the same force that you've been using here and here and here. That's 40. Okay, but they told you that the frictional force here is 10 newtons, so you replace it with 10, and then the angle for frictional force is 180. It's this whole thing. So just memorize, weight is 90, normal is 90, and friction, or like the opposite force, is 180.